Good afternoon. I'm Jeroen Baars. I'm a data scientist at the waterboard HHNK. So that's the waterboard above Amsterdam. Today I'm going to give current, small introduction. The current setting, what I see in changes, what we as a waterboard see in changes in water security. Then an HHNK vision on water security, which I help to implement with some novelties. And then my perspective on these developments, what we want to share, how we can collaborate, and how do you work in data science in this whole setting. So first, I thought I'd start with AI. When I was in high school, this was the picture of AI. So you had a couple of models, and on this one is better. Here you see the time axis, and here you see the amount of parameters for a model, so maybe the complexity of AI models. And if you look at this, you see that it's logarithmic, but you have a couple of models, they increase in size and they are becoming more complex. But if you look at my school career, so from 2006 in high school to now, the boom is going up like this. You got a lot of complex models, a lot of large models, everything in AI is changing. We got more parameters, we're going to 1 trillion. And if you look at the density in the graph, we got a lot of more models and a lot of more possibilities now. So this shift for us in the waterboard is of course a possibility to check what we can do in the future and if we can introduce these solutions into our problems. So I think also what we got, another thing in the water world is we got of course the changes in climate. I think these are well known, but I will highlight some for us. You got of course the change in amount of precipitation over the years. So we got more precipitation, it's increasing in total volume. It's also, we've got the precipitation shortage in the summer. So you got, I think, more extremes, more precipitation in the winter, more extreme or severe droughts in the summer. And also we have more peaks, so more storms or extremities, where you have some days with heavy rain or some days with 20 millimeters rain, and these days are increasing over time. So we're seeing challenges and we're seeing growth in AI. And at the same point, we also see they call it a perfect storm. We see some changes in all of our work. I'm working for water security, sewage treatment, and for water systems. And there are a lot of changes happening. We've got changes in the workforce. You see the labor market changing. You see our workload changing because of these storms, because of new challenges. But also because we don't have that much amount of labor market anymore to fulfill our needs. And we see changes in regulations. We see stronger regulations, which we need to adapt to. So I think these three things together is what made a shift in our water security tax. We have a vision now for 2030 that I will show later. We see these extreme peak situations. We see shifts in the endurance and extremities for our dikes. So we want protection against peak floods, and we want to check the precipitation, but at the same time we want water management during severe droughts. So together with the shifts in possibilities, we want to fulfill our duty of care in this shifting world. We want to make sure that the water security is still in place and that we can have a secure place for our people inside our waterboard. So I think 2 years ago, we made a vision for the long term that we want to have a data-driven approach to solve these problems, to get to know, to approach this shifting world. So we said we want to centrally store our data at a waterboard. We want to make sure that the data is also validated. And from that centrally stored data, we want to make sure that we can do something with our permit and enforcement. We can use machine learning or deep learning or other things when needed. We can do our evaluations on this data. We can do our scenario studies on this data, and we can do our disaster management on this data when needed and make sure that it's always available during disasters. In this vision, we want to also have the value of measurements. We talked just shortly about gaining from data to insights. And we want to make sure that we not only store our data centrally, but we use a data-driven approach to get continuous insight into our system. So we want to make sure that we always know the condition of our water security system. So how do we see this? We have the safety of our, let's say, dike. We have our norm, so what we say when it's under this norm, we have a problem, and we have our critical line. And we want to know what's happening to our dike. So is the degradation of our dike, at what point are we now? So you know the lifespan of your dike, and you want to know where are we now in this whole graph. So if we are at this point, you can do, of course, an evaluation in time, and I think that's how we do it now. So at some point in time, you do an evaluation of your dike, you check what's happening, and we want to go to continuous insight in this degradation cycle. So that's our focus area for water security 2030, so our vision. And this condition of the dike is dynamic. This is not happening in just one normal slope, but it can happen because of the degradation of materials. You can have animals digging, which can make a sudden drop in the condition of your dike. You have your ground decline or erosion of ship waves. These are all things that can happen to your dike, and you want to gain continuous insight into the condition, so you will know at every point what's happening, how this is happening, and you don't have, for example, one measurement at the flat point of the animals digging at the blue rate, and then it drops, but you know that that drop is happening at the point it's happening. For HHNK, how do we do this? I think Erik Vastenburg, that's at HHNK, our expert in water security, he said we have a couple of dominant failure mechanisms. We want to measure this, we want to check what's happening, and we want to go to parameters to measure this. For us, this at HHNK, this is, for example, the erosion of the outer slope, micro instability, and the overflow. So if you know this, and if you have your vision to get continuous insight, you get to some point, we want to measure some parameters to get to know these insights, and get to know when these mechanisms are happening. So our focus is on the continuous insight, of course, and risk-based management. We always want the actual estimate, and we want to find a way to detect these changes. So what do you need to measure? How do you get to these insights? And how do you see the effect of these changes on our evaluations? So at the center of it all is the data story of our dike. And now I've get to the point, how do we do this? What do we measure? I will show some brief insights, but I think the rest of the presentations will show more on how do we do this and more insights. And I'm getting to the data science perspective of what we learned as a data science cluster in our waterboard, and how do we want to work with models, data sharing, and these developments. So first we have, I can't get back. We had a case study at one small part, and in this case study we did an evaluation, and if we saw that some novelty has a green light, we are going to upscale it to more places, and we're going to check where is it necessary, how can we use it, and how can we use these insights. One of the things, for example, is the phreatic line. This has, as a parameter, influence on our failure mechanisms. So how can we measure this? We built on IoT sensors to measure this, and we built on a machine learning model together with partners on how to measure this groundwater time series. And from this groundwater time series, you can get insights, you can get information, and you can work on this. So this is one of the things how AI is used in our waterboard, or can be used in our waterboard, and we're experimenting with. Another thing was, for example, continuous insight in drought. So if you know your precipitation shortage in the years, you know what's happening, you can maybe also build an indicator to show how is your drought in your dike evolving. What's happening, do you have a time series for that, and what can you measure? Other things, for example, is that we can move to, you have AI evolving, but you have also a lot of new data sources. We can move to drone time series. So instead of one aerial image in a year, we can move to a couple of them in a year, and we can make a time series. For example, this one is taken recently, and I think we took one after the storm this year. And you can get to a high detail, but you can also see, okay, if we put 2 time series of drones, so 2 images over each other, what happened to our armor, what happened to our dike, and what's happening, and can we say something about what does this do for our failure mechanisms. So you can see here, the red arrows are the shift in our armor during the storm or after the storm, so we can know, okay, do we need to react on this? Is this something that is a possible problem or not, and what do we do with this? But we get this insight from this data, and now we can work further on what do we do with it. One of the other things, we work together with HKV, and we also work together with Weatherskip. I will come back to that later. Is, for example, the AI toolbox. The AI toolbox is an idea, and then Joost will talk about this later on how to detect the armor, the vegetation, the cracks, the digging, and how to do this all with AI. And you will go in depth on that. So you got all these kind of things of time series, you got all the insights you get from the new data sources, and possibly new AI. And together with that, we also have some other things evolving. Eric was especially proud of this, is that we have, for example, LiDAR in the iPhone, and to the right you see on the phone the digging that happened on the dike, and you can get an inspection on your office of what's happened in the field. So if, for example, we have a drone flight, we detect cracks, and we say maybe this is something we want to evaluate, you can, on request, do a LiDAR phone scan from someone in the field, and you can send this to the office, and we can check, okay, is this really a problem or not? And we can work with our data in, I think, a smart way. So for us, this brings everything together for the waterboard on continuous insight. So you have your graph over there of your degradation of your dike, and you can get your AI toolbox, you can get your time series, and you can use everything together to create a strong combination of data, but also information from this data to get continuous insight and on-demand extra data to check what's happening in your dikes. And this is up to now what we did as a waterboard, what's happened in Water Security 2030, and after my academic career for 4 years, I'm now working at a waterboard. I studied data science. This is my first job, and we got to evolve our data science department together with these developments. So we got some insights for this, and we got some things, okay, how can we share models? That's also in the AI toolbox, and we got some questions for this. And I think that's, I got one more slide before that. I was getting to my AI developments. We've got, of course, the vision for 2030. We got a plan of approach, a small pilot done and work in progress. So you see all this work we've done. We turn this button, so we say, when are we going to increase our complexity and ambition? And as a data science department, during this, we've got some insights that happened. And I think these are good to share, and these brought up some questions, and I think these questions we can talk about later in the discussion. So of course, we have a proof of concept at some point. You have your crack detection, you have other concepts, you have models. And it's always nice that at some point you say, we can do this, we can do crack detection, we can work with it, but at that point you say, we want to use this, and you want to go to production. And for us, that was really a challenge. How can you go to production? How can you make sure your IT infrastructure does everything in graphic cards, cloud, data, everything is in place to run the model while you're doing a drone flight, for example. So we want to make sure that we can do this. So that's more like the scalable and shareable standard part. We want to make sure that everything is standardized. We want to make sure that we have templates for this, so that every data scientist uses the same template, and that these templates can always be deployed in the same way on a robust framework. So we're always ready for this. And then the other part will be, if we have this baseline as data scientists, and we have all these developments. How can we share them with the community? How can we make sure that everybody can work on them? I think we had a discussion just now and Joost will talk about this later. We want to share everything as open source. We want to share the solutions, but if we share them and if we share our model and our weights and our data, and at some point Brabantse Delta wants to work with this and has a new model, how can they feedback loop this into our shared solution? And how can we make sure that we are also aware of these developments? To show some other examples on how we want to work with this. For example, for collaboration, we worked on the crack detection together with WeatherSkip and with HKV. But with WeatherSkip we said, okay, we have 350 cracks in our dikes, we label them, this is kind of a task, and we want to go further with this, so we want to increase it, and WeatherSkip did some drone flights, they shared the data with us, and together with WeatherSkip and the data scientist, we labeled 884 cracks extra, so we can make an addition to this model. But of course, now is the question, how do we share this model with WeatherSkip? If they advance further and want to do it on their own, how do they feedback that to us? And how do we make sure this collaboration keeps happening, and how do we find each other? Because this was an accident that I know Stefan from WeatherSkip as data scientist, but there are 21 waterboards and I don't know everything. Another thing is, for us as a vision, is this standardization and sharing. So I was talking about indeed the data, the labels, the models. How do we share this with the whole field? So this is one of the questions I think is for me worth answering, how to share, keep collaborating and keep each other up to date. And the other thing is for me, if you have shared these models, these developments and these things, there are also, in AI you see the big boom, you see changes in the field, you see shifts. We can't keep up with all the changes. As a waterboard we have a compact workforce, we want to make sure that everything we do is effective. How do we see the fundamental changes happening, and how do we implement this, but also how do we share this? For example, the crack detection, there is I had the foundation models. This is a shift in AI. You had machine learning, deep learning, and now foundation models. And machine learning was not that complex. Deep learning was more complex models, and foundation models meaning that you have models that are so big and trained on so much data that what you do with them is just fine-tune them on your data, because they're already kind of general for these kind of examples. This, for example, is segment anything model, and what this model can do is take a picture and segment every object that's on the model. And that's what we're also doing with crack detection. So if you have this model, you can say, I want to count the cucumbers. So you need to tag the cucumbers, but you already have them segmented. You can see them, you can see where they are, and maybe you can even find the biggest one on this picture because you know exactly what the form of the cucumber is. And this model is come out like half a year ago, and 2-3 years ago we started with the UNet, and we don't know yet. We need to test it. Maybe our model is already a fossil, maybe it's not, maybe it's still working as good as we think it is. But if we have this shift in AI and if this shift in fundamental approach to things, so you are going to stop deep learning and go to foundation models for some problems, how do you share this possible shift as well? So I don't only want to share data, models, but also how do we use which technique, and what's the best practice now for this kind of approach. So I think for me, in the end, we have the changing climate, workforce, AI, we have big ambitions, we also have big progression, and later on we'll talk about this. But every waterboard has these challenges, and also in the field, of course, there are other challenges, people working on this. So we don't want to reinvent the wheel, we want to progress as our waterboard, but how do we share these developments effective, these big shifts, these trained models, these standards, and of course with WeatherSkip it was for us really great that we could like 5 times our data set. How do we find this collaboration as waterboards? And I think you said the network, of course. But these are questions I had as data scientist and some insights we had in data science and in my career.